Hi, greetings everyone. I am BIBHORR, an aerospace engineer, and I am currently affiliated with UBH and CIR, wherein we have teams working progressively towards developing robust solutions and applications for futuristic space missions. For the 2021 Flight Software Workshop, I am presenting how Linux can be deployed in spacecraft applications, and I shall be discussing its pros and cons. So let's begin. Starting with the need of large advanced software systems. The human desire to explore deep into the space calls for developing spacecrafts that can tackle numerous tasks at the same time. And in order to accomplish this, large and more robust onboard software systems are required that play an integral role in spacecraft avionics. Similarly, with the ever increasing requirement for more efficient capabilities and better performance of spacecrafts, there is a need for large software systems built to compensate for advanced hardware requirements and added additional security. Moving ahead, here is some background. Traditionally, onboard flight systems involved languages like C, C++ for writing scripts with or without real-time operating systems. And Linux was conventionally thought to be unfit for flight software applications due to uncertainty in real-time operating systems integration. However, the last decade has drastically shown an increase in deploying Linux in space applications by several space organizations, firms, and manufacturers. Moving on, we have Introduction to Linux. Linux is an open source, community driven operating system. It is an elongated version of Unix. The source code being open, Linux has a greater flexibility in terms of modification as per users' needs and requirements. Linux allows for soft real-time. Linux supports MTD devices through Unsorted Block Image File System (UBIFs). Another advantage of Linux is that it is compatible with majority of processor platforms. Moving on, here are some interesting facts about Linux. As of 2018, Linux is deployed on world's fastest 500 supercomputers. It has been deployed in several space missions. Japanese bullet trains have deployed Linux for automating the control systems. Some of these interesting facts suggest how Linux can be a powerful tool in developing future space applications if the risks or limitations associated with it are mitigated successfully. Moving on, there are some of the Linux distributions that have been released time to time. SUSE Linux Enterprise Server is designed for servers, mainframes, and workstations and is in use across several industries, primarily computer software industry. CentOS is another free enterprise class computing platform that strives to maintain 100% binary compatibility with its upstream source, Red Hat. Some developers have noted that it lacks certified cryptographic protection. However, it is more flexible. Then, Slackware has a higher level of security, stability, and cleaner configuration for several operating systems. In order to deploy Linux in space applications, it is essential to understand booting process in Linux. Let's begin. First one is BIOS, Basic Input Output System. BIOS is put up whereby it loads and performs some system integrity checks and ultimately provides control to MBR. MBR stands for Master Boot Record. MBR loads and it holds the information about grub and finally executes it. Then comes grub, which stands for Grand Unified Bootloader. Grub loads the default kernel image and has knowledge of the file system and initted images. Kernel executes sbin init initial program. Init executes run level programs, and finally run level runs and passes control access to the operating system. This is the booting process in Linux. Next we have Linux file structure. The first is bin. This directory retains user executable files. Boot. It contains bootloader related files, static bootloader, kernel executable and configuration files. Includes files like kernel, initted, grub files. Next is dev. This directory contains the device files, which includes every hardware device connected to the system, terminal devices, USB, or any other attached device to the system. etc contains the system configuration files required for the host computer, includes startup, shutdown scripts. Home directory storage for all user for personal user storage. Lib. It contains shared library files that are needed to boot the system. Then we have media, temporary directory for removable devices. Moving on, MNT, a temporary mount point or directory used when the administrator is repairing or working on a file system. Then comes opt, contains optional add-on files from vendor supplied applications. Then root, it is the home directory for the root user and every directory or file starts from here. Sbin contains system binary files. These are binary executables used for system maintenance. TMP contains temporary files created by the user and the system. USR contains shareable read-only files, executable binaries and libraries, man files and other types of documentation. Then we have VAR. It contains variable data files and temporary files, includes log files, MySQL, and other database files, web server data files, email inboxes, etc. SRV contains server-specific services data. Proc contains information about system resources. MISC, it is meant for miscellaneous purposes. Moving on, we have Linux user permission types. There are 3 user-based permission group types: user, group, and other. Let's begin with user. User denotes the owner of the file, does not impact other users. Next one denotes the group that is assigned to the file or directory. Again, other users' actions remain unaffected. The last refers to all other users. Let's move to the next. Linux permission types. There are three permission types: read, write, and execute. That is R, W, and X. Read refers to user's authority to view and read the contents of the file. Write refers to user's authority to write, edit, and modify a file or directory. And the final one, execute. It refers to user's authority to execute a file or view the contents of a directory. RWX are the symbols for read, write, and execute, respectively. Moving on. These are the symbolic representations of some Linux permissions. The symbolic representation consists of a code indicating the set of permissions that will be changed: owner, group, others. A symbol indicating how we want the change to be: adding, deleting, or setting identical to another value. A code that specifies which permission should be. As a general rule, symbolic permissions are more useful when we want to make a simple change, such as adding write or execution permissions for one or more classes of users, or when we want to make the same changes to multiple files without affecting other permissions. For example, adding write permission without compromising the permission. Moving on. These are the octal representations. Octal notation is a numerical system for modifying the permissions on Linux. A 724 octal combination, for example, can be decoded for owner, group, and other permission, such that owner denoting number 7 can read, write, and execute. The group is only able to write, while other is only able to read. chmod is a command line utility that is used for manually managing the access and permissions to files and directories on Linux. chmod is simple to use while using octal notation. The structure of the command is chmod followed by the octal permission you wish to set, and then followed by the file or directory name. Now we have Linux commands. ls. This command enables us to know which directory we are in, and all the hidden files can be seen by using the command lsa. cd. This command is used to get into another directory. Since this command is case sensitive, one must type in the name of the folder exactly as it is. mkdir and rmdir. This command is used when we need to create a folder or a directory, while rmdir is used to delete a directory, and it can only be used to delete an empty directory, and that directory containing files can be deleted by using command rm, which is mentioned in the next point. mv. This command is used to move the files. For renaming a file too, this command can be used. Moving on, we have locate. This command is used to locate a file. It is used when we don't actually know where the file is saved. Touch. Touch command is used to create a file. It can be any txt file or empty zip file. cp. This command is used to copy the files. It will be used for both the file to be copied and where to be copied. pwd. This command gives us the absolute path, that is, the path that starts from the root. Next, echo. This command is used to help us move data in most cases. Nano. Nano is used for text editing and can recognize most languages too. df. This command is used to see the available disk space in each partition. du. This command is used to know the disk space usage of a file in the system. Zip. Zip command is used to compress files. Unzip. Unzip is used to extract files. Hostname. This command displays one's hostname and IP. Linux is in popular use in nanosatellites and has been used in several CubeSats and other spacecrafts. Falcon 9, Dragon spacecraft are all powered by Linux. Application programs provide the mission-specific logic to determine how the various subsystems are handled. Such application programs include electrical power system, GPS, global positioning system, attitude determination control system, S-band and UHF managers, and managers for the scientific payloads. It finds greater deployment in communication systems that handle the telecommand telemetry link with ground. Much of the satellite software is developed with desktop PCs with common tools used for C development on Linux. Alto 1 CubeSat utilized the Linux run applications for the onboard software. Since the onboard computers have lesser real-time constraints, Linux can be put to use without any special real-time adaptations. Finally, we have pros of deploying Linux. First of all, Linux offers compatibility with wider range of hardware systems, allows to choose among a variety of hardware architectures. Open source code allows identification and correction of codes in much lesser time. It offers flexibility in debugging and development. The parts of the code can be reworked on desktop systems and can then be channeled to the avionics. It allows to meet quick turnaround in projects by speedy development through collaboration with its larger developer base, allows easier integration, data compression, scripting, security layer, coding, algorithms from across industries. It does not incur any costs as it is community driven, open source, and hence offers no licensing fees. It features memory separation, advantageous in a way that crash in some part may not affect other processes or systems. Supports multiple file format systems. It supports various communication protocols that make interfacing with other devices trouble-free and uncomplicated. Moving on, optional soft real-time operating capabilities. Being an open source, it offers vendor independence, allows parallel program-wise updates to the system, helping reduce development turnaround. Then come cons of deploying Linux. Linux requires more lines of codes to manage the exchange of data between processes. Longer context switching is another disadvantage of Linux. Kernel module requirement for responding to interrupts cause the latency issues. And finally, Linux is not designed to be an RTOS, real-time operating system. We will be summarizing summary. Linux is an open source, community-driven operating system. It is cost-effective and offers vendor independence. It supports various communication protocols, allows parallel program-wise updates to the system, helping reduce development turnaround. It supports multiple file format systems. Overall, Linux is beneficial with few cons that can be worked upon for the mitigation. Linux can be efficiently be utilized in space applications. Thanks for listening patiently.